The idea of hypersonic aviation is becoming clearer every year. Although many studies in the field of hypersonics still remain at the experimental stage, the Hyria startup team has no intention of giving up on its goal of creating a hypersonic passenger aircraft. Today, we'll be telling you about the Quarter Horse project, an unmanned hypersonic aircraft, which is an important step for all of mankind toward hypersonic travel. For most people, hypersonic aircraft, like hypersonic weapons, represent a technological breakthrough for the 21st century, where science fiction becomes part of our reality. However, like the vast majority of such instant miracles of science, hypersonics have more than 50 years of development behind them. In fact, for some time, hypersonic technologies gathered dust in the depths of secret laboratories due to indifference on the part of the military. But today, they play a significant role against the backdrop of a fragile balance in the geopolitical arena, which has brought world superpowers to an even fiercer rivalry. Historically, starting with rocket launch experiments and North America's X-15 rocket plane in 1959, hypersonic speed was achieved using a rocket engine, with no alternative. However, poor fuel efficiency limited the practical use of rockets to propel aircraft over long distances. The proportion of fuel that rocket-powered aircraft had to carry could be as high as 90%. Leaving little mass available to accommodate the design features and technologies needed to ensure commercial aircraft-level reliability and safety. Simply put, it's difficult to imagine who, in their right mind, could approve a bus project with 90% of the weight being gasoline. But modern hypersonic air-breathing machines, such as a ramjet engine or scramjet, are quite capable of putting long-distance hypersonic travel into practical use. Their main advantage is their relatively high fuel efficiency, measured in terms of a thrust performance parameter called specific impulse. This is the engine thrust divided by fuel consumption. Although turbojet, ramjet, and scramjet engines are equivalent as forms of jet propulsion, each of them has a number of fundamental differences. Turbojet engines can reach speeds from a standstill of up to Mach 2 but are not capable of maintaining speeds of Mach 5 or more. At the same time, ramjets and scramjets can easily overcome the speed barrier of Mach 5 but cannot operate stably at low speeds, providing aircraft with safe takeoff and landing. By the way, this is why the lion's share of hypersonic inventions are not reusable. For example, modern hypersonic missiles first rise to altitude and gain speed using a conventional rocket engine, and then either glide back to the ground at hypersonic speed or turn on a scramjet engine for hypersonic propulsion. So why not combine turbojet and ramjet? The Hyria team thought, and they started working on their own Chimera engine. By the way, this name was not chosen by chance. After all, like its ancient Greek namesake, Chimera is also a hybrid. It's a turbine-based combined cycle, TBCC, engine capable of switching between two modes, turbojet and ramjet, allowing the quarter horse to take off and land safely at low speeds and maintain stable flight at hypersonic speeds. To keep the quarter horse from overheating, the Chimera has a pre-cooler that lowers the temperature of the air entering the turbojet engine, allowing the engine to squeeze a lot more performance out of it. Before it switches to scramjet mode, considering that the Pentagon is currently developing hypersonic weapons using combined cycle engines, it's especially impressive that the startup Hermes, albeit with government assistance, managed to design, build, and successfully test its own engine in 21 months, spending only $18 million on it. As the basis of its TBCC, Hermes chose the J-85 turbojet engine from General Electric, which was previously used in the Northrop F-5 Freedom Fighter light fighter and the Northrop T-38 Talon trainer. Before anyone even had time to be surprised by the first version, just 1 year later, news had already appeared about a new iteration of the Hermes engine, Chimera 2. This time, the team decided to take as a basis the more powerful Pratt & Whitney F-100, installed in the well-known American fighters McDonnell Douglas F-15 Eagle and General Dynamics F-16 Fighting Falcon, and which had recently celebrated not only 50 years of faithful service but also over 30,000 flight hours. But the new product will no longer be the quarter horse. It will be the next brainchild of Hermes, the Dark Horse, a larger reusable hypersonic aircraft that the company is developing to solve U.S. defense and national security problems. A speed of Mach 5 or more is remarkable, but only if your aircraft's body can withstand such extreme temperatures. After all, Hermes intends not only to break the speed records of the legendary Lockheed State Route 71 Blackbird but also to reach its altitude of 80,000 to 85,000 feet, which you definitely shouldn't attempt without a reliable glider. Here, the team had to really rack their brains, analyzing what high-temperature metal and ceramic materials they would need. Potential candidates included advanced titanium and nickel alloys, as well as superalloys that are structurally functional at temperatures ranging from 1000 to 2000 degrees Fahrenheit. Although some believe that nickel is too heavy for airframe construction when talking about speeds greater than Mach 6, the choice here lies in the field of carbon-ceramic composite materials, whose temperature capabilities extend up to 3100 degrees Fahrenheit for reusable devices and 3600 degrees Fahrenheit for single-use applications. Hermes found the answer in purchasing V3D Sapphire and Sapphire XC industrial 3D printers, calibrated to print complex parts from the heat-resistant, corrosion-resistant Inconel 718 nickel-chromium alloy that can withstand temperatures from 423 degrees Fahrenheit to 1300 degrees Fahrenheit. This solution also reduced the team's costs when creating parts for their Chimera engine. According to Hermes engineers, they used other modern materials for the quarter-horse components, but most of the airframe is made of good old titanium. The quarter-horse's sleek, streamlined design resembles a sharp blade fused to the body, like a blackbird, and its 40-foot length is comparable to the previously mentioned 46-foot Northrop T-38 Talon. However, the planned test will almost certainly force the company to make at least minimal adjustments to the appearance of the device in the future. Let's check them out. Last year turned out to be extremely productive for the startup, as it immediately began testing the quarter-horse Zero Malawian Kwacha's ground stand used to check the main systems and their integration into the aircraft. The prototype was built in just 6 months and successfully passed all planned goals as part of testing. The Air Force Arnold Engineering Development Complex, AEDC, at Tullahoma, Tennessee, in just 37 days, carried out various tasks. Among them were demonstrating human factor evaluations, pilot-in-the-loop steering and controls, demonstrating the proper state of the vehicle and flight deck during a loss of link, evaluating radio frequency, RF, latency, and ground handling qualities of the integrated systems, as well as demonstrating remote command and control taxiing. Having completed testing in early 2024, Zero Malawian Kwachas became the first of 4 planned test vehicles for the quarter-horse program. By March of 2024, Hermes presented the next prototype, 1 Malawian Kwacha, with the task of remote takeoff and landing. It took the team about 7 months to assemble it, and only 21 days to run all the test tasks. But this time, instead of AEDC, tests were carried out at Edwards Air Force Base, culminating in taxi tests at 50 miles per hour with full afterburner. The team has 2 more prototypes ahead, 2 Malawian Kwachas and 3 Malawian Kwachas. Moreover, the first one is already actively being built at the Hermes plant in Atlanta, Georgia. It's expected to receive the Pratt & Whitney F100 engine instead of the GE J85 found in the 1 Malawian Kwacha. The main goal of 2 Malawian Kwachas will be to break the sound barrier and demonstrate autonomous supersonic flight below Mach 3. Hermes has not yet shared technical details about 3 Malawian Kwachas, except for the fact that it's a test version of Chimera 2. But according to the roadmap published by the company, the task of the 4th prototype will be to demonstrate the turbojet to ramjet mode transition in flight and break the all-time airspeed record held by the State Route 71 Blackbird, which the team has been striving for so long. Responsible for test management, the flight deck was created by the startup from scratch to support off-grid, standalone operations in austere environments. The cockpit includes seats for the pilot, payload operator, for operational analysts, and several observer seats. All this fits in a special high-performance computing center, HPCC, with an isolated climate control zone, providing reliable protection for critical flight equipment. Externally, it looks like an ordinary transport container, which makes it easily deployable in any part of the world. All of these efforts, including the Dark Horse, should lead us to the Halcyon, a hypersonic passenger aircraft capable of over 125 transoceanic routes. For example, one Halcyon flight from New York to London would take about 90 minutes, which sounds crazy by the standards of the current airliners we're used to. The first flight of this engineering marvel is scheduled for 2029, but for now, the path to Halcyon is blocked by 2025 and 2026 testing of the quarter-horse 2 Malawian Kwachas and 3 Malawian Kwachas prototypes. But given the pace of development at Hermes, for some reason, we have no doubt that these guys will bend over backward to do everything efficiently and quickly too. Do you think the team will be able to present their magnum opus, Halcyon, in the next decade, or will it take much longer? Share your thoughts in the comments below, and if you enjoyed the video, please leave a like, subscribe to the channel, and hit that notification bell for more content like today. Thanks for watching, and we'll see you in the next one.